Okay, well, I can see we just hit 1 minute after the hour, so I'm going to go ahead and get started. My name is Matt Thomas, and thank you for joining the USGS Landslide Hazards Seminar. This meeting is hosted by the Landslide Hazards Program at the USGS and is co-organized with contributions from Stephen Slaughter and Jamie Kostelnik. And for folks that are new to this meeting, you have the ability to submit questions via the chat window or to use the raise your hand feature in combination with your microphone and video camera. We're going to wait until the end of the presentation to take questions, so you feel free to type them in the chat window, but in the meantime, if you're not intending to speak, just please keep your microphone muted and your video camera off. Mark, I'm going to go ahead and turn it over to you to introduce Brian.
Thanks, Matt. My name's Mark Reed. I'm with the USGS Landslide Hazards Program, and it's my pleasure to introduce Brian Collins, who's also with the USGS Landslide Hazards Program. Brian is both a geologist and a geotechnical engineer, so he wears both hats. He keeps his professional engineering credential going as well. Brian did his undergrad at Purdue, his master's at CU Boulder, and a PhD in geotechnical engineering from UC Berkeley with Nick Sitar. He started with the USGS as a Mendenhall postdoc, and he's been here about 16 years out here in Menlo Park and Moffett Field in California. He's done considerable work on rock fracture mechanics, rockfall hazard and risk, rainfall-induced shallow landslides, ground-based remote sensing systems such as LiDAR and radar, so quite a spread of activities. And he's worked with the National Park Service in Yosemite, he's worked in Alaska, Prince William Sound, and the San Francisco Bay Area, so a lot of different areas. But he's participated in numerous landslide crises responses over the years, and that's an important element of the USGS Landslide Hazards Program. The style and nature of these responses have evolved over the years, and Brian will be talking about some of that evolution today. So welcome, Brian.
All right, thanks very much, Mark. That was a really nice introduction. I appreciate that. And it's my pleasure to be able to present on this topic. This is something that I think a lot of us, if not all of us, have touched upon at some point in our careers with landslide science. I do want to thank the conveners for this, in particular, Matt. I think the seminar has just been great over the past years, and so kudos to all of you for organizing that. And also, before I begin, I want to thank the co-authors that you see here. This is very much a group effort. As Mark mentioned, I've been here for 16 years. I'm going to summarize 20 years of USGS response to landslide disasters. So a compilation of a lot of people and a lot of experiences went into this. So thanks to all of them. So as we all know, landslide disasters occur worldwide. And, you know, that's not going to change. Society continues to develop into steeper areas. There's climate change effects that we'll be needing to take into consideration. And so essentially at some point in the future, there will be another landslide disaster. And so it's our responsibility as landslide experts to be able to be positioned and to have the expertise to be able to respond when emergency workers ask for our assistance. Those emergency workers are typically the first people on the scene, firefighters, police officers, and they're not landslide experts. They may not know exactly what they're dealing with. On the other hand, we obviously have that background, but we don't work in that emergency realm all the time. And so there's that point where we have to really start to communicate, and communication is really a key in responding to landslide disasters. You'll see I'll mention that several times throughout the talk about how we go about doing that. So the questions here and the motivation for putting this talk together has really come down to what do landslide experts, what can they do? How can they share their knowledge? And what are the best practices for landslide disasters response? So this presentation was actually put together for an invited keynote talk at the World Landslide Forum in Kyoto, Japan last year, presented online. And there I had the opportunity to sort of bring all these experiences, bring all these different responses that the USGS had been involved with, and queried a lot of different people and tried to develop that, try to get these best practices down on paper. And so what I'll do today is I'll share some examples and case studies from that, trying to wrap our heads around what we do in landslide disaster response and what we've learned and how best to go about it. So first, a quick note about what is a landslide disaster. I've defined it here very broadly. It's something that causes undesired and devastating societal outcomes. And that's very broad, but you can see that the last slide that I showed, it had a big dust cloud coming from a rockfall. That's affecting infrastructure. And for those emergency managers, for those land managers, that is a disaster to them. There may be fatalities, there might be injuries, there's definitely going to be property damage. And so that's what they're dealing with. Compare that to this slide here, the Santa Tecla, El Salvador landslide in 2001. You know, killed many people, destroyed many homes. That is also a disaster, obviously a different flavor, but these are responses and where we have to provide that expertise in each of these situations. So to begin, I'm going to start with two quick examples of just what it is that we do. I'm going to use two examples that I'm familiar with personally, responses that I worked on, just to sort of paint a picture of the type of things that we do when we're on the ground, when we're talking to emergency responders. And then I'll go into some background about the factors that affect responses and the types of landslide responses. And the types I've categorized in terms of the time frame that we're viewing them. I'll go into more detail about this in a bit, but essentially looking at and compartmentalizing the case studies into looking towards the past, what we learn from the past, dealing with the present, the hazard situation that's affecting us now, and then the third is looking toward the future and saying what can we learn from the situation now to help us prepare for future events or potentially prevent future events from happening. And so then I'll just end with a quick summary of progress and a couple conclusions that we can draw from all of this. Before I get into some of these details, I do want to say that this talk is not meant to come across as definitive or this is how the USGS does it and all of you should do it too. That's not at all the intent. Rather, this is really put together as an invitation to the landslide response community. I know that we all deal with this in some ways. States have to deal with this all the time, whether it's the State Geological Survey or Department of Transportation or some other agency. I'm painting this picture from the USGS perspective because we've been doing it for a long time, but it's certainly just one perspective. So there's also lots of other needs that might be taken, and I'm sure the international community, different countries have different ways to go about this. That all said, in looking through all the case studies that we've responded to in the USGS, I did find broad similarities, at least in terms of what we do and what we've learned. And so it's, as I mentioned, it's an invitation to start these conversations before that next disaster strikes so that we're prepared and we can learn from one another. What do we do in a landslide disaster response? It's fairly simple, and it's communication. We're providing technical information for decision makers. We're typically not making decisions. Those are left to those emergency personnel that have to coalesce a lot of different information and then decide what's best for that particular situation for their community. And so really what we're doing is we're helping those decision makers understand the hazard, the landslide hazard, so that they can make informed decisions. So for example, and I'll go into some of these details with some of the case studies, but if an emergency manager needs to know what the likelihood of something else coming down onto the road, and we say there's a medium likelihood or a high likelihood or something like that, that doesn't necessarily mean that they're going to close the road. They have other considerations that they may need to account for, such as that road is the only emergency transport lane to get some injuries out or something like that. So, we don't have all the facts. Our job is to really provide the hazard facts to them so that they can make those decisions. So let me start with these two quick examples that I've been involved with. These are both from California. One's in the Bay Area. There was a debris flow in Sausalito, a small community. that led to one injury, and then I'll highlight some experiences from Yosemite. Here, this is a rockfall that led to a fatality and 2 injuries. And so I'm not going to go into full details on these. I just want to sort of paint a picture and just showcase what a response looks like, what's done. So this is Sausalito, as I mentioned, small community in the San Francisco Bay Area. It's densely populated and built on very steep hillsides with a history of previous landsliding. This particular event happened during a fairly large, significant rainstorm. It was about 1,200 cubic meters in volume, and it destroyed several homes. You can see here in the image on the right, some of these homes built on stilts, as I mentioned, very steep terrain. It blocked roads, ruptured gas pipeline, tore apart some electrical lines. There was one injury. Somebody was in the upper level of one of the houses and actually slid down. And the rescue workers were the first ones. The fire department were the first ones on the scene to pull that person from the wreckage. What did I do in this? Well, the first thing I needed to do, so I have a project in the San Francisco Bay Area. We study landslides. I have knowledge of this. And so this was sort of right next door or in the region of our offices. And so I extended my efforts to them. And the first thing to do is basically make connection with the emergency managers. You know, there's no landslide expert at the scene when I arrived. And so I had to introduce myself as such and say, I'm with the USGS, I have landslide expertise. Would this be helpful? You know, do you know what you're dealing with here? That's going to be typically welcomed. I mean, people are very, very welcoming when you're offering help. Obviously, it's a very stressful situation, and finding the right person to talk to might take some time. Once that was done, the first thing they really wanted to know was, you know, what's the potential for additional landslide movement? And so evaluating secondary landslides, looking at the headscarp, looking for tension cracks, trying to make those sort of observations and passing on those observations. Our landslide expert trained eyes can maybe see things that other people don't. And so passing on that information was critical. Providing some context on previous landsliding. You know, landslides in this community have occurred, but they're more like a decadal type thing. And so there wasn't really any institutional knowledge of previous landslides in this area that the emergency workers were familiar with. And so letting them know, yeah, there have been landslides before. They've been destructive. This is similar to that. That just helps people have some information rather than thinking this is the first time this has ever happened and what do we do? One interesting thing was to share information on cleanup protocols. So this was 2019. USGS had just been involved in Oso, a Washington landslide in 2014. And, you know, in the subsequent days of following this event, there were questions about, okay, how do we go about cleaning this up? And I said, well, let me put you in touch with some partners in Washington state that actually just had to do this. There's communities up there that just had to, you know, deal with hazardous waste situations in the landslide debris and cleanup and things like that. And I think that can be very helpful to have, again, our experiences, our connections extended and bridging those relationships. So what does this all come down to? Providing answers to the first responders and the local managers. What can happen next? Is it safe for rescue workers? You know, recommending spotters, for example, before people go into the debris to start looking for additional fatalities or injuries. Providing suggestions and at least some comments on mitigation measures that they might want to take prior to the next storm. That's the kind of information that we provide, that we can provide from the landslide expert perspective. Next case study or next example, again, just to go through some of the things that we do when we're responding to these types of events. Here's some rock falls that occurred in 2017 in Yosemite National Park. Yosemite is visited by millions of people per year. For those that haven't been, there's extremely steep granitic rock cliffs. They're prone to rock fall periodically. And in this case, there was about a 300 cubic meter rock fall that fell off of the southeast face of El Capitan, shown here. And unfortunately, there was one fatality and an injury. These were climbers that were planning to climb one of one of the routes on El Cal. I was not there for the immediate response. The park geologist was. And so there's a whole nother story to be told for that. But I can say that immediately the search and rescue people that were trying to get the injured person out and evaluate the extent of the other person's injuries, that's decision making on the spot as well. What's the likelihood for additional rockfall? How quickly can we do this? And so obviously somebody who's familiar with rockfalls, like a park geologist, can provide that information on the spot. A day later, there was a much larger rockfall, about 10,000 cubic meters, that came down, and that's what you're seeing here in the picture. And there was an additional injury. There was a piece of fly rock, basically a piece of debris that flew up and over the trees and hit somebody driving down one of the roads. That led to a very large dust cloud, obviously, and the closure of the road. And so that's when I was called in to provide some assistance. And again, what are the questions that are going to be asked and what can we do? Well, what's the potential for additional rockfall? That's a key question. Can we, should we keep the road closed? Can it be opened safely? What can you tell us? And so things that we did in this case is we assessed the source area for additional instability. We're using spotting scopes. There was a helicopter available in the early part of the response to get very detailed photos and eyes into that source area. We analyzed both archived, so we had pre-event LiDAR data, and then we created models with structure from motion from photographs taken from the helicopter and from the ground to assess the volume of the next possible instability. And this was a really interesting case study. We worked with colleagues in Switzerland. We were collecting the data, they were processing the SFM models while we were sleeping. And so in the course of 24 hours, because we were working with colleagues in different time zones, we were actually able to really quite efficiently get to some of these answers. And so estimating what that next volume might be that comes down, is it larger or smaller than what's already come down? What's the likelihood that it's going to continue past the distance of the previous rockfall or not? And so providing those sorts of answers, putting the event in context with previously recorded rockfalls. What's the history of rockfall from this cliff? Have there been others lately? And again, same questions here. We're providing answers to the first responders and the local managers. We're providing answers to those questions. What could trigger additional motion? And how big and how far might an additional rockfall go? So I hope those two examples sort of give at least some portrayal of the things we do, the questions we're asked, the types of data that we can gather. We'll revisit 3 case studies here in a bit and go into a little bit more detail about some of the lessons learned from those. But before I do that, I did want to briefly discuss some of the factors that affect landslide response. And I've organized those here according to 6 different categories, and we'll step through each one of these. In terms of the mechanism and type, obviously, the type of landslide, what it is going to determine what sort of expertise is needed. So I'll say, is it a natural or anthropogenic trigger? For example, if it's anthropogenic, if it's, some construction was cutting the slope, then obviously those are the people we're going to want to talk to understand the stability conditions. If it's a rockfall versus a debris flow, it's a very different expertise. You're going to want to tap into the right people that have that expertise. Hydrology, fracture mechanics, experience with these events will be critical. And then obviously the type of landslide will determine what you do, if any, in terms of monitoring. So will there be some kind of repeat LiDAR or GPS tracking or in situ instrumentation to monitor potential other movement from the slide? So the mechanism and the type are critical. That's an important factor for determining what you do in a response. The number and the geographic extent obviously are another important factor here. Is there one landslide we're dealing with or thousands? And if it's many and if it covers a large geographic area, then we have to be open to the fact that we might be dealing with a lot of different emergency managers. We might be dealing with different municipalities. In the case of an earthquake that spans a large area, you might be working with different even state governments or regional governments. This, in this case, when we're dealing with thousands of landslides, it's really a triage discussion of we have limited resources. What can we do with those resources and where best to dedicate them? There'll be hard decisions here. We obviously can't do everything. And so we're going to have to do our best to say, here's what we can provide. The size of the landslide will obviously also affect the type of the response, the scale of the disaster. Scales are obviously is related to landslide runout in many cases. Are there multiple types of landsliding from a larger landslide? So this is the Oso, Washington landslide in 2014. This had a debris flow off the front, a rotational backscarp, all sorts of things in between. And so a large landslide like this might require, again, lots of different types of experts here. Hydrologists are going to be needed brought in to understand what the flooding hazards might be, or the dam breach hazards associated with a landslide blocking a river, which is what happened here. And also a very large landslide might block your transportation routes in and out. And so access from multiple directions might be necessary. And again, OSO provides a really good example of that. You can see here the landslide is blocking the road, and so emergency crews had to come in from this direction and this direction, and those lines of communications weren't exactly easy to make in the early stages. And so that will obviously affect the type of response or how you go about organizing the response. If you're providing expertise to people on this side, hopefully you have a means to do it on this side as well. The potential for continued activity, this is critical. This is one of the questions that obviously emergency managers are going to ask of landslide experts. What's the potential? Is this a stable situation, or is it continue to be unstable? What's going to happen next? How quickly can we get our emergency personnel, our search and rescue crews in to do what they need to do? What are we looking at? And so you can obviously imagine that in the case of an earthquake, we have aftershocks. And so there is that potential. That might not be the case for other types of landslides, for example. I have highlighted here this really interesting landslide from the Gorkha, Nepal earthquake in 2015, which had some unfortunate circumstances. So I was part of a team that evaluated this landslide, and in the immediate short term, we determined that the risk from additional landsliding was low. That there weren't any other tension cracks or backscarps forming. There's probably going to be a lot of rockfall. The people of the village were told to stay away from this area. Unfortunately, in the longer term, monsoon rains came and reactivated a lot of this debris and led to additional destruction and fatality in the village. And so when we consider what's that question, potential for continued activity, sometimes that timeline extends longer than the immediate part of the hazard that we're trying to wrap our heads around. We have to be thinking a lot longer in some cases. The location obviously will depend, or the type of response will depend on how easily you can get to the location. So is the landslide occurred in an urban environment where you can drive there, or is it remote and you will be using helicopters? How easily and efficient can we respond and get the people that need to help with the response? How quickly can that occur? What type of monitoring methods can we effectively use if it's in a remote setting? And I note that there's a number of really great technologies that have come that have been developed over the past 10 years or longer in some cases, but the use of remote satellite imagery is great. We can learn a lot before even getting onto the ground. Obviously, satellite, radar, the use of drones, these are all critical tools for that can help working in especially remote locations. And then the final aspect that affects the type of response you'll do is the cultural setting. We have to keep in mind that responses are requests for assistance. We're providing our expertise, and we have to be sensitive to what the needs of the community are. In addition, for obviously an international response, there's lots of logistical hurdles. There's permissions, visas, language barriers, and things like that. Working with a translator will be needed. But the most important thing about that I want to say about the cultural setting is to make sure that we all recognize that the local partner should be the key for communicating the messages out. And so we're providing them with the expertise, they're making the decisions, and we should leave the communications to them rather than us taking the lead and saying, here's what I think about the hazard. So sensitivity to all those things is also critical. Okay, those are factors that go into landslide response. What are the types of landslide responses that we do? And so I hit on this earlier. What I've done is I've looked at all the responses that I put into this proceedings paper that we had put together, and was able to see that they could fit into these three categories: providing past context, addressing the present hazards, and improving future assessments. And again, I do want to recognize all my co-authors on this. I worked particularly closely with Mark Reed to come up with this framework, and I think it fits really well for what we do. And so when we're looking at the past context, what we're doing here is we're asking, what do past events tell us about the current disaster? What can we provide? What expertise do we know about from having some experience with previous events that we can provide to the emergency managers at that time to deal with the current situation? Addressing the present hazards is really dealing with what do we need to do now? What needs to be done to mitigate this current situation? And then looking at the future assessments is really what can we learn now in order to prevent something like this from happening again. And so the tools that we might use are many. We're going to be answering questions, obviously, but we might be mapping, we might be performing some modeling, we might be installing monitoring equipment, collecting data, information mining from historical accounts. So all these things go into that kind of response. So taking everything into consideration here, I'm going to step through three case studies, one that highlights the past, the present, and the future, those three different landslide categories. And I'll describe each event, and then we'll talk about, I'll provide some details on some of the lessons learned from those events. And so I already highlighted these two, Sausalito and Yosemite events. And so now I'll focus on these next three, Osa, Washington in 2014, 2005 La Conchita landslide in Southern California. And then for the future perspective, looking at what we're learning now about landslides in Glacier Bay and coastal Alaska to inform on potential hazards in the future. So we'll start looking backwards. We'll look to the past. And I've mentioned some of this information before, but I'll highlight it here because I think it's important. Those first responders, again, might not have any experience with landslides. They might not know what they're dealing with. And so that's our cue to get involved and to provide them with that kind of expertise and those answers. So just answering simple questions. What is this event? It's a landslide, it's a debris flow, it's a rock fall. We've had these here before. Here's how they've been dealt with. Here's how they've evolved over time. Well, we can answer those questions. We can provide that information in a lot of cases. So we'll look at the La Conchita landslide in Southern California from 2005 as that an example of looking towards the past to help inform the current situation. La Conchita is a small coastal community and built at the base of a 180-meter tall coastal terrace formed of weak sedimentary units. And in this case, the landslide occurred from above average precipitation in that year. There were two events in this community about 10 years apart. In 1995, and you can see the outline in green here in the image, there was a slow-moving complex slump that led to some homes being damaged, but no fatalities. So the landslide moved slow enough that people were able to get out of the way. And you can see that it didn't really make it down into the community too far, just on the edge. Unfortunately, 2005, 10 years later, part of this debris of the scarp remobilized into a rapid debris flow, and 36 homes were damaged with 10 fatalities. And you can see here the outline in yellow where that went. So you can see that obviously, and I'm going to talk about the 2005 event, but you can see that the value of having an understanding and experience with the 1990 event was going to be critical. In the initial hours of the event, after the event, that's the emergency responders. And in this case, there was a local government geologist that was able to get to the scene very quickly and do those rescue operations, assess the immediate life safety, set up perimeters. In the following days, state and federal partners, including the USGS, got involved. And their role was to answer questions, obviously, and to provide that background. They also provided hazard assessment. And again, the goal was that decision making with the best available information. So, giving the emergency managers, the decision makers, the ability to make that decision to open up or close a road, or keep a perimeter line, or allow people back into their homes to retrieve their possessions, things like this. I'm sure the question, what's the likelihood of additional activation, was being asked. I'm not going to go into the details that I did for the Sausalito and Yosemite event in terms of what exactly they did. Rather, for these next 3 case studies, I'm going to just talk about the lessons learned. But I will say, if anybody's interested in the details for that, we do have this proceedings paper available. I'll put up the URL at the end from the World Landslide Forum this past year. Lessons learned for the La Conchita slide were really many. I talked with Randy Gibson about this considerably, and he was the one that was involved heavily in this response. Among the most important lessons learned was the importance of rapidly sharing the objective findings with all the parties all at the same time. So, emotions were running high. Some people probably felt that, the community shouldn't be there anymore. Some people felt that the community should absolutely be there, and they're going to rebuild exactly where those homes were. Lots of different opinions, lots of different emotions. And so getting involved in that and talking to one person and then another person might get you into trouble, essentially. And so, just sticking to the facts and disseminating that knowledge to everybody equally is really critical to be able to provide that information objectively. In this case, because there was such a strong local feeling to that, one of the lessons learned here was that the use of a non-local expert was helpful. So somebody that could come in and say, "Hey, I don't have any, I don't have any situation here personally or from my agency. I'm just going to tell you how this looks to a landslide expert that has dealt with this before." And so that was helpful. A couple other lessons learned from this were dealing with sort of the media and legal implications. And so because this landslide led to lawsuits and lots of fingers being pointed and things like that, it was very important to exercise prudence when talking to the media, to stick to the facts. The media might ask questions such as, would you have built your home here? Or would you rebuild your home here? And that's not ours to answer. The questions that we can answer are, what's the immediate risk? What's the hazard? Stick to the facts, not your own personal opinions about the situation. And then, again, the legal and political issues that would come out of something like that, those kind of questions being asked, of being aware of that situation is always really, really important. Okay, I'll move on to the next case study, which addresses the present hazard situations. For this, I'm going to return back to the Osa, Washington landslide from 2014. Here, we're going to be asking questions about what's the situation now and how do we deal with it. is it safe to conduct rescue and recovery missions? What's the short and long-term expected hazard? Can we reopen these roads? Can we allow occupants back into their homes? So as I mentioned, OSO, this was landslide in 2014, Northwest Washington. And the community is called the Steelhead Haven community. It's actually not in the town of Oso. Oso is located to the west a little ways, but the closest town has been named, or the landslide's been named after the closest town, so we call it the Oso landslide. This community here was built on the banks of the North Fork Squamish River. There's a 180-meter fluvial terrace, and back of it, you can see here, failed. These are composed of glacial deposits, and again, this similar to La Conchita, failed in an above average precipitation year. Also similar to La Conchita, there were multiple events, and here they were 8 years apart. In 2006, this slope failed as a slow-moving slump. No homes damaged, no fatalities. The river was partially blocked, but then was able to reroute itself, reclaim its channel. Unfortunately, 8 years later, this landslide failed in a rapid debris flow avalanche, and 50 homes were destroyed, essentially the entire community, resulting in 43 fatalities. So the initial response, again, was by the emergency responders. And again, in this case, similar to La Conchita, the local government geologists were able to get to the scene really quickly and start assessing what needed to be done. This was all focused on rescue, pulling people from the debris. In the days and weeks that followed, this then switched over to a recovery effort. The decision had been made to recover the bodies of all the people who died in the landslide. And so this really led to a much larger effort of having hundreds of search and rescue people working at the distal end of the landslide. And so that was a call for landslide experts, USGS involvement, and others to assess the ongoing hazard potential to protect and to give warning to those recovery operations. This included installing instrumentation and monitoring during the search and rescue operations. There's a lot of details that went into this response. I'm not going to cover here. As I mentioned, I'm just going to sort of hit the highlights of the lesson learned. But for those interested in this event, there's a new paper that Mark Reed led. It's published last year. It's called When Hazard Avoidance is Not an Option, Lessons Learned from Monitoring the Post-Disaster OSO Landslide, and that's in Landslides Journal. So I would invite anybody interested in learning more details about that response to visit that paper. The lessons learned from this event. One critical thing is understanding, just how many people you might end up talking to for this. This was a very large event with lots of moving parts, lots of different agencies, and being able to establish trust with the representatives of all those agencies in the thick of the response can be difficult. So as much as possible, a lesson learned is just to use opportunities to build those relationships before something happens. And if that means, participating in this seminar and, getting to know some people, that can be of tremendous value at some point in the future. One thing we learned from this was the value of having available monitoring instrumentation and the expertise that goes along with it. It's not just the hardware, but it's the people behind that understand these systems and being able to rapidly deploy these things. Here we put out seismometers and GPS receivers, and there was a lot of expertise that was already in-house for that. And it was fortuitous that we had some of that instrumentation ready to go at the time. But more importantly, as I mentioned, we had the expertise behind that could sort of coach the people that were involved in the response to be able to use this effectively and provide those timely warnings in case something was in case instrumentation was showing that something could happen. Another key item here is being able to adapt our technology. So a lot of us are in the landslide research community. We use these tools, but they're for research. we're not often asked to make a decision or provide some interpretation of the data in the next 15 minutes. And that's kind of the operational side of things, is when you're being able to adapt what you do in research to an operations is difficult. And so being aware that you might be asked to do that. And obviously along with that goes uncertainty, and as much as you can, being comfortable with uncertainty or being able to wrap your head around uncertainty is really important. So that's another lesson learned for dealing with responses. Okay, the final case study I'll go into is looking at the future and what can we learn from an event now to help us inform what might happen. And so I'm going to turn to a case study from coastal Alaska. This is one that Jeff Coe's been involved with a lot. This is going to be looking at data collection and long-term monitoring of some landslides in Glacier Bay, Alaska. And so, and I should say Glacier Bay, but we've actually started working in Prince William Sound as well. And so these landslides that we're looking at are related in some respect, in that they all have the potential to cause tsunamis, and these could affect local communities and shipping traffic in this area of Alaska. We're dealing with landslides that are potentially millions, hundreds of millions of cubic meters in size, potentially being destabilized from deglaciation and climate change effects. We don't know how many events are out there. We don't necessarily know where they might occur next, but we do know where some of them are. And so this is really saying, what can we learn from those ones that we know about to help us inform how we might go about dealing with any potential disaster from the future. And so what Jeff and his team did in Glacier Bay was looked at a series of 10 landslides that occurred over about a 4-year period, and looked at the effects of temperature change on those, and then also just getting a handle on what are the sizes of those landslides and what's their potential for runout. In 2021, last year, we got involved in a large landslide in Prince William Sound, the Barry Arm landslide. Again, this is a disaster that hasn't happened. It obviously has the potential. And so, we're doing everything that we can now to prevent and to be prepared for things that might happen in the future. So response in this case is a little slower speed compared to maybe some of the other case studies I've described. Here we're really looking at a lot of data. We're analyzing satellite imagery. We might be looking at climate data, looking at potential temperature trends, thresholds, and evaluating some instabilities that have not fully reactivated or have not activated into a full-scale landslide and potential disaster. So monitoring, modeling, things like that. What are some lessons learned from this sort of forward-looking perspective? The use of archived remote sensing imagery is critical. I mean, having these baseline data sets really will help inform us to be prepared for something in the future. Being able to proactively recognize hazards and instability, having that trained eye with those archived data resources gives us that ability to hopefully plan. And, in this case, we have a lot of landslides that were documented that were non-damaging. They weren't landslide disasters, but using that information effectively to help prepare for something that could happen is really the key. And one thing we're learning, again, that I highlighted in the OSO case study, was that scientific partnering, being able to make those relationships with all the other key players, having those open forms of communication is critical. So a quick summary, I guess, in terms of the progress that we've made in responding to landslide disasters. Preparation is key. I've hit on this in a number of the case studies, having ready to deploy data collection methods, instrumentation, using archived imagery, having these baseline LiDAR data sets or imagery data sets is critical. Adapting new types of technology, so being able to rapidly conduct satellite tasking, using the latest infrasound or seismic methods, having all those key skills will be important. And I'll highlight this third bullet again on the next slide, but communication. Being able to really, have those relationships established or cultivate them quickly and be able to provide those messages really on a timely, fact-supported basis is critical. Having those skills, those communication skills ahead of time is really helpful. And a general experience in talking to all the co-authors for this paper, all the people that have responded to this, technologies are great. They're obviously changing the way we do things, but there's really no substitute for being on the ground and being able to talk with that emergency manager one-on-one or in person to understand what they're dealing with. So that is something that really hasn't changed, is that interpersonal communication skill and being able to wrap your head around the same situation that they are. So as I mentioned, communication is key for all of this. And I've taken these bullet points from a presentation that Stephen Slaughter's put together about communication for geologic emergencies, distilling your message down into plain language, keeping the message simple and memorable, something that they remember once they've left you and moved on to the next thing. And then obviously, if they come back to you, having that consistent, repeatable message to reinforce what it is that you find is the most important aspects that they need to walk away with. Being able to have those skills, those communication is really the key for all of this. I highlighted here a figure taken from a paper that Rick Wooten had put together for the North American Landslide Conference back in 2017. And I thought this was really interesting. This is the North Carolina Geological Survey's Landslide Response Activity Framework. Lots of different bullets. But you can see about 25% of those bullets have something to do with communication, whether it's providing media briefings or providing information to those people that are going to do those media briefings, communicating with emergency management people, talking with stakeholders. So communication is always critical, always a key for all of this. So I'll sum up a few conclusions. In the end, what we've determined is that the core job is actually quite simple. It's being able to communicate the fundamentals of landslide science. It's taking what you know as a landslide expert and being able to share that message and get that message across to the emergency managers, the decision makers that then have to move on and deal with the situation. Unfortunately, it's a fact. The number and severity of the landslide disasters is likely to increase. Our society continues to build into steeper areas. And, I can't say that despite all of our efforts in hazard prevention, that we won't be faced with another landslide disaster. And so, as I mentioned, that's the motivation behind this, is to let us think about that, to help us get prepared for that. And so, again, this was the USGS perspective from all of our case studies, but the point is really to open up those avenues of communication, and this is an invitation to share your own experiences and develop those relationships if need be prior to a disaster happening. So that's all I have for today. Here's the URL for the paper that I mentioned that's published in the World Landslide Forum on this dealing with landslide disaster response. And I've also put up the reference for Rick Wooten's paper about the North Carolina Geological Survey's experience. So I'll leave that up there for a sec. And that's all I have. Matt, let me know if I should keep this up or stop sharing or what happens next. Thanks.